Okay, so we'll start. So as you all know, this is just for question and answers about the lectures or anything else you want to ask about. So feel free to unmute yourself or you can ask something in chat and I'll go through it. One thing I'll note is that I mentioned in the email, so instead of in the style of a lecture, one of the other lectures I gave a video talk of a talk that I gave. And so I posted 3 talks about 3 different issues. So one's a kind of walkthrough of what's happening in decentralized finance. One has to do with something called front running, which is an issue that you should understand now because you understand how Ethereum works. You understood how Bitcoin works with mempools and how mining works and things like that. And so there's some issues with it. Lots of consequences for what you might want to do in DeFi. It's something, if you're doing a project, you should think explicitly about whether there's front running attacks that apply to the project that I'm doing. And another thing that comes up a lot in the projects is people assume that you're able to have a smart contract that goes to a website and gets something, or it gets the exchange rate between US dollars and ETH or something like that. But on Ethereum, you can't ask for anything that's off chain. The reason you can't ask for anything off chain is because the miners, there's no guarantee that when they go and visit that external link, that they're all going to see the same thing, right? Because the website might present itself differently to different miners depending on where in the world the miners are. The website itself might change. So some miners go before the change, some miners go after the change. And so the miners might start disagreeing, and it's not because the mining software is bad. It's not because of anything wrong with Ethereum. It's because of this external source. There's a problem with the external source. And so you can't have a blockchain system where those kinds of problems, that's a kind of problem that could happen, right? You don't want your blockchain system to be dependent on the correct functioning of things like websites. So the easy solution is just to turn it off and say that you can't reference anything. So then could you actually get real world data and put it in a blockchain? The answer is yes, but someone has to grab it and put it in. So they're called an oracle. So an oracle is basically someone that goes and grabs the information, puts it in, and they have a lot of power because if they put the wrong thing in, then they could, if it's some sort of financial system, for example, if they put the wrong price in, then they could cause a lot of people to make money or lose money. So anyway, so the talk will go through different systems of oracles. So like how to build a whole infrastructure, where you maybe have more than one oracle and people are voting on whether the information's good, and you can kick people out, or they have to post some amount of money and you can slash the amount of money they have if they misbehave and things like that. So how do you kind of deal with that problem? So anyways, oracles show up in a lot of final projects. And so it's just another good kind of general topic to know a little bit about if you want to do work in this space. So anyway, so there's these 3 talks, and then next week, again, the lecture itself will be online, so you can watch it in your own time. And during the classroom time, we'll have question and answer. And since it's the last class, I'm expecting a lot of questions about the exam and things like that. And but anyways, this will focus more on the currency aspect of Bitcoin, not in terms of how it works, but like, what do you expect from a currency? Does Bitcoin satisfy it? Could you have like a currency that looks more like the Canadian dollar? Could a central bank actually issue cryptocurrency? So these are all topics that we'll cover in the next lecture. So I'll record it at some point and upload it before next Tuesday. Okay, and the final project, you'll note that I offered an extension, and so now I put it in the website so you have the date. Okay, questions? Once again, just unmute yourself or ask in chat. And if there's no questions, then we'll have an early day. So a question about the final exam, will it be multiple choice or short answer? The answer is probably a bit of both. So it'll probably be multiple choice, true, false, and short answer. So it's an in-person exam. You'll write it on paper. COVID, hopefully with COVID that will be possible. If anything happens, like say there's another lockdown, or if I just had COVID, so I probably not going to get it again. But if there's some sort of disruption or something like that, then we'll do a truly multiple choice question. But right now the plan is to have it in person. You can bring a cheat sheet, one piece of paper with anything you want written on it. And yeah, the question format will be mostly multiple choice and short answer. Okay, so a question on DeFi. What are some use cases and real world examples? So in DeFi, I hope that the talk itself addresses it. So that actually is the kind of the purpose of the talk itself is to walk through it. Let's go and pull it up, but
your work can feel much smoother with Monday.com WorkOS.
Let me say, I'll talk through it. Okay, so what we cover in the talk are, so DeFi stands for decentralized finance. It's primarily services that are available on Ethereum. And there's about 4 or 5 services that most people use. And then there's maybe like a long tail of other kind of weirder things that people do. But most people want to launch a token. So you have a token, the token can represent anything. It might be a token that you have some service and you want to have your own custom currency. So you can have a token for that. It might be a unique token that represents like digital art or something like that. And so you have a token for that. It could be some token that's used for voting on things. So you have some protocol and you want people to make decisions about it. And so you issue tokens that allow them to vote. It might be a token that represents some real world asset. Like this is a token that's meant to represent a Canadian dollar or US dollar. So token systems are one of the big ones in DeFi. And so there's a couple standards, ERC20 and ERC721, that define a fungible token, which means that it's interchangeable. So if I give you, say, I give you $20 Canadian in paper money in a bill, you don't care which actual bill I give you. I could give you 2 10s, I could give you a 20. I maybe have 5 $20 bills. You don't care which one you get, right? They're all worth the same. There's no difference between them. There is a serial number on them, so it is slightly different, but you just don't care about the differences between them. So we say that that's fungible because it's kind of interchangeable. You don't care which one you actually get. And then if I have 5 paintings and they're all different, then you care about which actual painting you get. So those are non-fungible. So anyway, so ERC20 is a standard for fungible tokens, 721 for non-fungible tokens. Now you have a bunch of tokens, they're circulating. What do you want to do with them? You want to be able to exchange them. So I have a token of one kind and I want to exchange it for another. So Uniswap and other exchange services, they're part of DeFi. Another thing you might want to do is borrow tokens. So let's say I have tokens of one kind and I want to borrow a token of a different kind. That's something else that you can do. So Compound would be an example of a lending service. There's other kinds of loans called flash loans that I go through. And they're kind of interesting because you can do them on Ethereum, but you can't do them in real life. You can invest in tokens. So you think the price of a token is going to go up or down. You can invest in it. One way of investing is obviously just to buy it. But what if you think it's going down, right? Then what do? Well, maybe you use the lending service. So you borrow it, use an exchange to sell it, and then you wait. And then if it goes down, you buy it back cheaper and repay your loan. So that's one way of doing short selling. Another thing you could do is go to an exchange and say, hey, I want a short position in this token. And what they'll do is they'll basically create it kind of synthetically. And what you can do is you can actually borrow money as well. And you could say, hey, I want to buy this particular token and I think it's going up. And instead of, I have $100, instead of just buying $100 of this token, I'm going to post the $100 as collateral. And what you're going to do is give me like $1,000 worth of the token. Okay, so I can leverage my position up. And if the token goes up, I make money on all $1,000 worth of that token. But if the money goes down, or if the token goes down in price, I lose money on all $1,000, not just my $100. I lose money on all of it, right? So that's called leverage. So that's another thing that's offered in DeFi. Yeah, anyway, those are the main categories of things that are part of decentralized finance. And there's hundreds of millions of dollars worth of assets that trade through DeFi services now. The other thing about DeFi I'll say is that if you have an idea of something, right, you can like just, as long as you can write the Solidity code for it, which you all can do now, you know how to post Solidity code to a blockchain. That's all you need to do, right? You write it up, you post it. Obviously, you have to advertise it or market it somehow. But if people decide they like it and they start using it, like you put the contract there, and people start using it, you don't touch it ever again, right? And there could be millions or hundreds of millions of dollars flowing through your contract later. Okay, question is, how are blocks created and validated in Ethereum? So there's two answers to the question. For the purposes of this course or the exam, they're exactly the same as Bitcoin. So that's all you need to know. I didn't go through and explain it in terms of it. So you're not responsible for knowing anything other than just assuming that it works exactly the same way that Bitcoin works. In real life, it does work currently very similar to Bitcoin. The data structures they use are slightly different. So they have a fancier version of a Merkle tree that they use. There's also a problem in Bitcoin where if you solve a block and someone else solves the block at more or less the same time, and their block becomes the one that's integrated in the chain, you lose all of your money. And so in Ethereum, they tried to fix that problem. So they, if you solve any block that attaches to the main chain, even if no one extends you, if you do have a valid solution, you're considered an uncle block, and you can still broadcast it, and then you get a portion of the reward. So I forget what the percentage is, but you get like a small percentage of it. So instead of 100% going to the person who created the block that's in the main chain, you get a split of it. So that's another small difference with Ethereum. And then Ethereum is in the process of updating. So they're updating from Ethereum 1.0 to 2.0. And in 2.0, they'll completely change the structure. They're not going to use proof of work at all. They're going to use something called proof of stake. So in a proof of stake system, when you do the consensus and you validate transactions, basically what you have to do is you have to take some amount of ETH, it's a lot, 32 ETH, and you have to, it's like tens of thousands of dollars worth of ETH, and you have to lock it up. So you can't use it for anything else. Then you attach a validating node to it, and your node validates transactions. And then when a block is mined, there's kind of like a lottery system. And so the people that stake the most ETH have the better chance of winning the lottery. But even if you stake, like say 1% of the ETH that's being staked, you should win the lottery 1% of the time. You'll be chosen, and then you're the one that's able to validate or to mine the next block, and then you'll get the mining reward that's associated with it. So no one's doing proof of work anymore. It's not a scarce resource. The scarce resource isn't your computational power. It's now how much ETH you own. And the arguments for it are that it's sort of financially, it's incentive compatible because people who want to validate transactions need to own a lot of ETH. They're probably going to do a good job of validating transactions, because if they do a bad job, then there's a chance that it's going to hurt the Ethereum blockchain system, and then the value of ETH will go down. And since by definition, they're the people that hold a lot of ETH, it would impact them negatively. So now it doesn't stop someone who wants to burn their own money to bring down the system. So there's a Goldfinger attack like that. But other than that, it tries to, like, smooth out different problems where people might try to manipulate a little bit to gain a little bit of an advantage. It's not exactly equivalent to proof of work. So in proof of work, for example, you couldn't go back 5 years, fork, and bring the blockchain up to the present, right? Even if you got 51% of the power, you still have to solve a proof of work for 5 years worth of proof of work puzzles, right, in order to bring the chain up. So there's this huge speed bump to going really back far in time and bringing it up. But with proof of stake, if you can get enough stake, it's a weird concept, but if you can basically go back 5 years ago and you can have enough ETH that would have been a majority stake 5 years ago, you can take over the staking system, and then you can fast forward, because now you have the majority, you can basically fast forward to the present time instantly, because there's no proof of work to slow you down. It just, you have to compute all the signatures and things like that, but that takes like a fraction of the time it takes to solve a proof of work. So you could bring it forward. So proof of stake, you have to assume that there isn't a 51% attack in terms of the stake, for the entire history of the blockchain. Whereas with proof of work, it's like, if you could get what was 51% ago 5 years ago, it's probably not going to help you much. So anyways, maybe you followed that, maybe you didn't, but anyways, it's just for your own interest. Okay, question is, developers try to write efficient code in order to pay less gas. Could you write code in C or assembly, then compile it to EVM bytecode to save more gas? So it's true. So developers are always trying to optimize gas. And there's some really weird things that you can do to optimize gas. The trade-off is it makes your code less readable. So it's harder to maintain. It's harder for new developers on your team to understand what's going on. It's harder for users if you're going to disclose your source code. It's harder for them to verify your contract. It's hard to give it to a security auditing firm to come in and say, yeah, that looks secure. I don't see any security vulnerabilities with it. So, making it really efficient. Yeah, anyways, it kind of obfuscates the code. So there is a trade-off there that sort of prevents people. Now, is there something you could do in C or assembly? So first off, so Ethereum runs on bytecode, EVM bytecode. So that is like assembly code, right? So at the end of the day, you compile down to EVM code. Your starting point is usually Solidity, okay? But there's no reason you have to start in Solidity. You could hand write your contract in EVM bytecode if you wanted to. You could use a different language. So there are other languages other than Solidity. There's one that's similar to Python called Serpent. And there's a few newer ones as well. And anyways, they also compile down to EVM. So there's no reason that you have to use a particular high-level programming language either at all, or if you choose to use one, you don't have to use Solidity. Could you have like a C-like Solidity? You could, or you could have an explicit subset of C, because there's certain functions that you need in Ethereum that C wouldn't support. And there's probably certain things in C that you could do that would be hard to compile down to EVM. But anyways, you could have a C variant and compile it down. It's probably not going to be more or less optimal. The compiler always introduces inefficiencies. If you write in a different assembly and then try and port it to EVM, once again, that translation process is going to introduce inefficiencies. So it's probably actually more gas efficient to program in Solidity, because that's a programming language that has a direct, that was developed specifically to compile to EVM. And so the correspondence to your high-level functions and your EVM bytecode is thought out. And EVM and Solidity 2 also does some optimization for you, right? So they automatically do it. And so, yeah, there's probably no chance that working in some non-Ethereum specific language is going to net you any optimizations. Yeah, and so anyways, now the one thing you can do is you can just write in bytecode or certain functions, and you'll see it. You can even do it in Solidity. You could be like, okay, here's a function, and then you can say, here's a block of bytecode, and I'm just going to drop the bytecode in, and it's like an assembly block, and it's in the middle of my Solidity code. Sometimes people will go in and they'll hand tune, one particular function or something like that to make it super efficient. Okay, any other questions? Okay, another question. When I look at GitHub repositories, there's BIPs and IPs. Can you explain a little more about them? Yeah, so these are, okay, so Ethereum is an open source software. And technically, there's no one that's really in charge, but there is an Ethereum Foundation, and most of the developers, the core developers, are somehow affiliated with it. And so if you want to change something, like say, for example, you want to change from proof of work to proof of stake, you need to have some sort of process, and you have to have the community buy in to doing that change. And so what they did is they tried to follow the same process that's used on the web. So on the web, there's also a kind of foundation called the Ietf that that tries to govern different internet protocols. So like if you want to know how does HTTPS work, and like what are the different fields that are in the header of the format that's used or whatever, that needs to go through a standardization process. And so what they'll do is they'll propose a standard, which is called an RFC, and then it's called an internet draft first, I guess, and then when it gets sort of approved, it's called an RFC. And so anyways, on Ethereum, you have a similar process. So if you have some idea for Ethereum, you need to really write it up. So it's exactly specified, like what is the exact change that you want to make? Where is it being made? What are the ramifications, et cetera, et cetera. And so you write that up in a document. It's called an EIP. EIPs are given a number so that people could say, oh, that's EIP 7129 or whatever. And it's easier to talk about. And eventually some of those EIPs will actually get formalized. And so at that point, they switched names to ERC. So like ERC 20, for example, is a standard for how to do tokens on Ethereum. It would have started as an EIP, something else. Yeah. And so another sub question is, can anyone propose an idea? Yeah. So as far as I know, anyone can write an EIP. I think there is a vetting process to make sure that the EIP itself is sort of self-contained enough, so they won't just publish like if you wrote something that didn't make any sense. So I think there is a bit of a vetting process, but you don't have to be like work for Ethereum or have any like special affiliation or anything like that. Like it's evaluated on the merits of what is written itself. So yeah, so you can propose it. Yeah, and then anyways, EIPs then turn into ERCs, and those are changes that have actually been implemented. A question about proof of stake. Can I explain about it? So I tried to already, I can sort of repeat what I already said. So the basic idea is that it's what happens at the consensus layer. So at the consensus layer, you have someone proposes a block, right? And then everyone validates the block, and then they can choose to integrate that block in the chain that they're working on, or they can choose to ignore it. And so at the end of the day, it's kind of like a voting process where you're voting on whether to accept or reject a block. and the amount of voting power you have is proportional to the amount of computational power you have in a proof of work system. Proof of stake is the same, except for instead of your voting power being based on the amount of computational power you have, it's based on how much ETH you have, for example, in Ethereum, and specifically how much you're willing to lock up. So you take a pile of ETH, you lock it up, so you can't do anything else with it. You lock it up for a certain period of time. And so if I lock up 32 ETH, I get a certain percentage of it. And if you lock up 32,000 ETH, then you're going to have 1,000 times more sort of influence than I will. And the rewards are also like given out basically in proportion to how much you lock up. So you're going to make 1,000 times what I'm going to make in terms of how much rewards you can expect. The main benefit of it is that you kill all the electricity costs that are associated with proof of work. So Bitcoin is very expensive. It has a huge footprint in environmental costs. The total amount of computation that's being used on Bitcoin converted into the electricity that's used to run the servers or the miners is kind of proportional to like a small country, right? Like there's more energy being used by Bitcoin than some entire countries are using for the households and the factories and stuff in the country. And so it actually is a huge footprint at this point. And so there is a motivation to try and reduce the environmental impact of cryptocurrency. Someone else asked about yield farming. Okay, so yield farming is a more advanced thing that happens in DeFi. Just trying to think if there's an easy way to explain it. Okay, so let's say that you let's start with an exchange. So with an exchange, what happens is you walk up to the exchange, I have some ETH and I want to buy some other token with it, okay? Now, I put ETH into the exchange and I get the other token out, right? And other people might come, they might put the token in and they might get the ETH out. Now, the question is, how did that exchange end up with a bunch of ETH and a bunch of tokens, right? And so sometimes exchanges are set up as companies and the company goes out and they buy a bunch of all the different kinds of tokens that they want to trade and it's from their personal supply. But what happened in DeFi, because this is decentralized, there's no company behind it. So what they said is any user could be the person that puts the tokens on the exchange. So you could walk up to an exchange and say, hey, I'm willing to fund, people who want to trade between ETH and this other token, I'm willing to fund it. I have some ETH and some of the other token. I'm going to give it to the exchange. And then when people buy and sell, they're going to basically buy and sell the tokens that I gave to the exchange. And what I'm going to get in return is I'm going to get a fee every time there's a trade. So the trade happens, it involves some of my coins, then I get a fee of it. And eventually I hope to make money with this fee. So what that's doing is it's providing me an income stream. So I'm taking my currency, I'm not using it for anything else. I give it to that service and I earn an interest rate, a rate of return, or a yield on that money, okay? So yield is the term that people tend to use. Now, exchanges aren't the only thing that operate like that. There's some lending platforms. You've got to decide if you're borrowing some money, it's coming from some other user. And so that user is getting some interest rate. And there's a couple other DeFi services that have the ability to pay an interest rate to the person that's providing the tokens that's involved in the service, okay? And then what people said is they said, okay, there's all these different kinds of DeFi services that allow you to earn interest. So let's say I have a big pile of ETH. Where can I get the highest interest rate, right? Or the highest yield? Should I go over and put it on Uniswap and exchange, or should I put it into Compound, or should I, convert half of my tokens into another kind of token and then give these to this service, or should I do a bit of both? And so then people decided to start making kind of like a middleman or middle person contract that will make that decision for you. So you just say, I have these tokens, I want to invest them somehow. And then that contract will go and figure out where you can get the best interest rates, and it might change its strategy over time depending on how things change. And so that service that sits in the middle is called yield farming. There's yield.fi is an example of a service like that, and there's others. And so they just have some strategies that the smart people at that company figure out to try and maximize how much interest that you make on it. So it takes you don't have to decide, and you don't have to mechanically go and distribute your funds to the right services at the right time. It just automates the whole process. So it's kind of like using a broker or something like that. It just, it brokers that you have some stuff you want to invest it in, it brokers that transaction for you. All right, last chance for questions. All right, so I'll see you all next week, hopefully in person. And yeah, bring all of the final questions you have about the course and about the final exam, and I'll be happy to answer them then. All right, bye everyone, have a good week.